In this tutorial, we're going to be taking a look at a review of fractions. These are skills and knowledge that you should have picked up in elementary school, and so we're just going to go over these, but these are all essential skills for anybody completing a high school course in mathematics. So, very quick overview. We don't need to go through some of this detail. These are the sorts of things we'll cover in class. I want to get on to doing some actual examples. So let's take a look at our first one here, working between mixed and improper fractions. So my first example, part A here, I have an improper fraction. So in order to convert this into a mixed fraction, we ask ourselves, what the number, what number of times does 5 divide evenly into 12? So some simple mental arithmetic. 5 divides evenly into 12 two times, because 2 times 5 is equal to 10. And then, well, what's left over from that? 12 minus 10 is equal to 2. And so this is equal to 2. That's how many times it goes in there. And then there's a remainder of 2. And so that's 2/5. So we have 5 goes in there 2 times, and then there's 2/5 left over. Now what about going the other direction? We've got 3 1/4. Now there's another way of writing 3 1/4. I just want to show you the option. You could have written this as 3 plus 1/4. So that's 3 wholes, and then 1/4 is the part. But if we want to do 3 1/4, well, that would mean, if we think of this literally as 3 wholes, that's the same as 3. But what is a whole when we're talking about quarters? Well, a whole would be 4 out of 4. That's what a whole would be when we're talking about quarters, plus 1/4. So 3 times 4, that's going to give me 12 quarters plus 1/4, which gives me a total of 13 quarters. Another quicker way to do this whole thing would have been, there's a bit of a shortcut we can take if you're comfortable with it, which is you just do a quick multiplication, which is you take the denominator and you multiply it into the whole portion out front. So 3 times 4 is equal to 12, plus the 1 that was already there, and the whole thing goes over the denominator that you were given. So the 3 times 4, that's where this part came from. And then the plus 1 was already present. So that 1, that's where that 1 came from. And we put all of those together, and we end up, of course, with the exact same answer we had before, which is 13 quarters. Moving on. When you have a fraction, you really should be reducing your fraction to lowest possible terms. And the way that you do that is through the idea of a common factor. That's what we're looking for here. So when we're looking for a common factor, we are looking for a number that fits into both of these. So what number fits into both 12 and 15? And there's a few ways that you can figure this out. If you can think about the factors, the things that go into it, what is 12 actually made up of? Well, 12 is 2 times 6, but 6 can be expressed as a product of numbers. So that's 2 times, and then 6 is the same as 2 times 3. What about the number 15? 15 is equal to 3 times 5. And now when it comes to common factors, that's literally what are the factors that these have in common. And you can see that they both have the number 3 in common. So our common factor is equal to 3. It's not looking very good because I'm at the bottom of the page. So we end up with, I'll write it up here, my common factor is equal to 3. So this is equal to, well, what is 12 divided by 3? 12 divided by 3, well, that's equal to 4. So 12 divided, we're basically doing the numerator divided by 3 and the denominator divided by 3. That's to get rid of that common factor. So 12 divided by 3 is 4, and 15 divided by 3 is 5. So 12 over 15 is the same as 4 over 5. That is now in reduced form. It's in its lowest terms. Sometimes you don't want to necessarily go through this whole process of writing out all of the factors. You might not want to write out all of the factors for 210. It's not as bad as you may originally think, but nonetheless, maybe we don't want to start with that. But what we can do is sometimes we can identify a common factor immediately and just start with that. I've got 60 ending with a 0. I've got 210 ending with a 0. So it is very obvious that there is a common factor here of 10. So if there's a common factor of 10, what is 60 divided by 10? That's 6. What is 210 divided by 10? That's 21. Now that we're down to 6 over 21, you might think, well, that's not so bad. 6 is equal to 2 times 3. 21 is equal to 3 times 7. And for this one, it comes out very quickly. We have a common factor of 3. So what is 6 divided by 3? That's going to leave a 2. What is 21 divided by 3? That's going to leave a 7. So 60 over 210 is equivalent to 2 over 7. So that's for reducing fractions. Whenever you get an answer in any kind of mathematical problem, you should be reducing your answer to lowest possible terms. Now let's take a look at addition and subtraction of fractions. In order to do that, you need to have a common denominator. And that's the lowest common multiple. Sometimes that's called the least common multiple of the denominators. So what do we mean by multiples of the denominators? It's quite literally that. We start with the number 6. In this case, that's, well, 9 and 6. What are the multiples of 6? We have 6, we have 12, we have 18, we have 24, etc. What are the multiples of 9? 9 times 2 is 18, 9 times 3 is 27, 9 times 4, 36. Now, as you can see, I've actually gone far further than I needed to here, because as soon as we get to the smallest number that is common between those sets of multiples, so in this case, it's 18. So the question we now ask ourselves is, how can I rewrite each of these fractions as something over 18 plus something over 18? I'm changing, just in the same way on the previous slide, I was reducing my fractions to their lowest form. Well, what I'm actually doing now is, it's kind of a way of thinking. Instead of reducing it, I'm increasing these fractions into another form with a higher common denominator. So what did I do to the number 9 to turn it into the number 18? Well, I had to multiply the number 9 by 2. So I have to do the same thing to both numerator and denominator here, because I don't want to actually change what the fraction means. So what is 4 times 2? 4 times 2 is equal to 8. 8 over 18 is exactly the same as 4 over 9. If we reverse that process and reduce this fraction, we would say, what's common between 8 and 18? It's the number 2. Divide top and bottom by 2, we get back to 4 over 9. Then I take a look at 6. What did I have to do to 6 to turn it into 18? I had to multiply it by 3. What did I have to do to the 1? I have to also multiply it by 3. So I end up with 3 in this case. And from there, my final answer, now that I have a common denominator, my answer is simply over 18. And now I add the numerators. The denominator stays the same. So 8 plus 3 is equal to 11 over 18. Quick look. Can I reduce this? No, I cannot. 11 is actually a prime number, so its only factors are 1 and 11, and so it has nothing in common with 18. Now, let's move on to another example. We have subtraction done exactly the same way. So I take a look at, now, another quicker way you can do this. Rather than just blindly writing things out, what I'm going to do is I'm going to start with my two denominators, 4 and 7, and then I'll say, well, 4 times 1 is 4, 4 times 2 is 8. Now I'm past 7, so let's go down here and make a bigger number. 7 times 2, 14. Now let's go up here. Keep going until you always get a bigger number or you get that common denominator or common multiple. So 4 times 2 is 8, times 3 is 12. That's still less than 14. Times 4 is 16. Then I go 7 times 3, 21. This one's going to be 20 next. 28. 24, and I would have finally reached 28. So there I have my common denominator, my least common multiple. So we go ahead and we rewrite our fractions equal to something over 28 minus something over 28. So what did I have to do to the 4 here to turn it into 28? I had to multiply it by 7. What did I have to do to the 3? I also multiply it by 7. I end up with 21 over 28. What did I do to the 7? I multiplied it by 4. What did I do to the 6? I also have to multiply it by 4. 6 times 4 is 24. Now you might hold on a second. I multiplied 4 by 7. I multiplied 7 by 4. Does that mean that I can always just multiply the two denominators together? Not quite. Multiplying the two denominators together will always give you a common denominator, but it won't give you necessarily the least common denominator. You want the least common denominator. It makes the mathematical operations or the arithmetic operations much easier. If I had done that, you can see over here, 9 times 6, well, that actually would give me 54. It turns out that my lowest common denominator is 18. So it's worth going through this process, because otherwise, if you use these larger numbers, if in this case I had used just 9 times 6, I would have ended up with a much larger fraction, and then I would have to go through the process of reducing it to get rid of that 54, turn it back down into 18. So in this case, I should end up with, most of the time I'm going to end up with things that I don't have to reduce further. We always have to check though. 21 minus 24, I'm going to end up with negative 3 over 28, and I take a last look, make sure that this is in a fully reduced form, and in this case it actually is, so we're fine. Next case, multiplication or division. We don't need a common denominator for this. The rule for multiplication is about as straightforward as you're going to find. You multiply the numerators together and you multiply the denominators together. Simple as that. So here I'm going to just extend this a little bit, and multiplying the numerators together, I get 8 times 5. That gives me 40. And then I get 25 times 24. Geez, well, hold on a second. I like to do these things in my head if I can, and that's kind of ugly. Isn't there a better way that I could have done this? And it turns out that yes, there is a better way we could have done this. So let's back away from that. Let's not resort to having to check things with calculators depending on where your mental arithmetic is. And instead, let's think about, since we're doing a multiplication, what we can actually do is we can consider this to be, you don't have to write this part out, but that's the number 8 times the number 5 over 25 times 24. You might think, well, big deal, you didn't actually change anything. But multiplication is commutative. We could say 8 times 5 is the same as 5 times 8. The order we write this doesn't matter. So when I look at reducing fractions, which is usually something that will make my life easier here, not only can I look at reducing fractions vertically within those fractions, but since it's a multiplication, I can actually look at reducing fractions diagonally as well. That's kind of messy, but hopefully you get the idea behind that. So what I'm actually going to do is I'm also, not only am I going to compare 8 to 25 and 5 to 24, I'm going to compare 5 to 25 and 8 to 24. And if I do that, it turns out I can make my life much easier this way. So backing that out, and now I'm going to take a look at, well, what about the numbers 8 and 24? What do they have in common with each other? Well, 8 and 24, 24 is just 3 times 8. So 8 divides into 8 one time, and 8 divides into 24 three times. Same thing, and of course I've chosen this question to illustrate this exact point. 5 divides into 5 once, 5 divides into 25 5 times. So if I were to rewrite this, and normally I wouldn't, but for clarity I'm going to do it for this tutorial, this is actually the same as 1 over 5 multiplied by 1 over 3. I would normally skip straight to the next step, and so we multiply the numerators together. 1 times 1 is 1. We multiply the denominators together. 5 times 3 is 15. So this works out to be 1 over 15, and as you can see there, I did very simple arithmetic. Everything was within the 12 times tables for doing this, as opposed to having to do the 25 over 24. Now here I have another fraction multiplied together. In this case, I have a negative improper fraction as my second fraction, but my approach is exactly the same as it was before. I remember that I can reduce any numerator with any denominator. Now 6 over 15, there's actually a reduction that can take place right away there. So I might go ahead and do this, and I'm going to warn you right now, things can get a little messy when you do this, so you want to try to be as neat as possible. What number goes into 6 and also goes into 15? When I say goes into, I mean is a factor of. And it turns out the number 3 is a factor of both of these. So 6, how many times does 3 go into 6? It goes in twice. How many times does 3 go into 15? It goes in 5 times. So 6 over 15 is the same as 2 over 5. 35 over 22, are there any common factors there? Turns out there are not. 35 is 5 times 7, those are 2 primes. 22 is 2 times 11, those are 2 primes, so they're not going to help each other out. But I can actually go one step further here, which is 35 and 5 have a common factor. How many times does 5 go into 5? It goes in once. This is where I warned you about things possibly getting messy. And how many times does 5 go into 35? It goes in 7 times. So I'm going to just write this out again just to show us what we have in the end. That means that what we really have here is the equivalent of 2 over 1 multiplied by, and instead of negative 35 over 22, I have negative 7 over 22. That, I've reduced this as far as I can, so now I just go ahead and do my multiplication. Normally I would go straight down to here. I wouldn't write out this extra line, but you can if it makes you more comfortable. Helps you keep track of things. I have a positive times a negative. My answer is going to be negative. When you're doing things by hand, I recommend you put your negative sign in the numerator. If you try to put your negative sign lined up with the fractional division, there's a good chance they could smear together, and then you're going to make some confusion. Did you really mean negative, or is it positive? So put your negative sign in the numerator. 2 times 7 is equal to 14. Oh, I missed a reduction. That's okay. We keep going forward here. And 1 times 22 is 22. I missed the opportunity to do a further reduction of this 2 with this 22. It's pretty obvious now that I've caught it, but that's okay. So now I'm just going to do this reduction. I'm going to reduce my final answer. And that reduction, I look and say, well, 2 goes into 14 7 times. 2 goes into 22 11 times, giving me a final answer of negative 7 over 11. And finally, let's finish up with some division. So when we are dividing, what we want to do is we're going to use the multiplication rules. The only thing we're going to do with the division is we're going to take the reciprocal of the second fraction, and that's important. It's not the reciprocal of both fractions, not the first. The reciprocal of the second fraction, which means to flip it over, and then just go ahead and use our rules for multiplication. So this first one is equal to 10 over 18 does not change. That is exactly the same. And then I change my division to multiplication, and I change my second fraction into the reciprocal of the second fraction. So now that I've got this, I just go ahead and make use of my rules for multiplication. So what are my rules? Well, they say that I can actually take a look at common factors. Now you might take a look, 10 and 18, hey, they have a common factor. 36 and 12 has a common factor. 18 and 36 has a really good common factor, but you might not recognize 18 as a factor of 36. So however you do this, just make sure that once you take out your common factors, you're honest about it. Now, at the very least, I would hope that you would recognize that 36 and 12 have that common factor. So I'm going to say that 12 goes into 36 3 times, and 12 goes into itself once. I've got 10 and 18. So I'm going to say, well, 2 goes into 10 5 times, and 2 goes into 18 9 times. And if you catch it, we get this all in one shot. Hopefully you can see, let's see, what color should I do this? Maybe black, I guess. You can see that we've got a 3 and a 9, a 3 in the numerator and 9 in the denominator. 3 goes into 3 once, 3 goes into 9 3 times. A bit of a confusing mess we've got here. So I'm just going to go ahead and I'm going to rewrite it one time so we can see what we've got. 5 over 3. Remember, we changed that to multiplication. Well, that one's just 1 over 1. So 5 over 3 times 1 over 1 is equal to 5 over 3. Finally, not terribly complicated, but I have added a little bit of complication because of this mixed fraction. So you might want to deal with that off to the side, convert that. What is 2 and 7 over 9? We talked about the rule for doing that. What I'm going to do is I'm going to multiply the 9 into the 2. So 2 times 9 is equal to 18. And then I'm going to keep the 7, plus 7, divided by the denominator 9. So 18 plus 7 is 25 over 9. So that's going to be my improper fraction that I use over here. My first step, I'm just going to go and say I did that work. If I do that work, if I actually write it out, I do it over here in rough. If you can do it in your head, 9 times 2 is 18, plus 7 is equal to 25 over 9. And in one step, I'm just going to go ahead and say I'm also going to convert this to multiplication, and I'm going to make this 21 over 18. If you wanted to reduce this fraction before you flip it over, that's okay as well. Just make sure you're only doing one step at a time until you're really good at this. You don't want to take any shortcuts. Actually, before I'm ready to do that, I want to, once again, let's take a look at reducing fractions. 21, 9, 18, and 25. So is this going to work out for me? Well, I've got a couple of things that stand out. I've got 9, 21. 21 is 3 times 7. Sometimes it's a good idea just to talk about what are these numbers. 5 times 5, there's actually nothing here that goes with 5s. But 21 is 3 times 7, so I'm actually going to say 3 goes into that 7 times, and 3 goes into 9 3 times. We've got an 18 here in the denominator. Well, 18 doesn't have anything to do with a 7. Doesn't have anything to do with the 5s here. So that's it. That's as far as we can go. So unfortunately, I left this one a little bit awkward, and that's too bad. But we can get through it. Think about quarters. Think about if you had 7 25-cent pieces. Well, how much would you have? 4 25-cent pieces is $1. Then another 3, that would be $1.75. So that means 7 times 25 is 175. And 3 times 18, 3 times 10 is 30, and 3 times 8 is 24. That works out to be 54. This is the kind of thing, if you needed a calculator to double check your math on this, or if you need to do a little bit of rough work at the side, that's absolutely fine. Now you might look at 175 over 54, you probably wouldn't want to have to reduce that. But because of the way we've done this, I don't need to reduce it. I've reduced everything before I did this multiplication. So I end up here, I've got my final answer, and because I was really meticulous about reducing my fractions before I did the multiplication, I'm quite confident that this is in a fully reduced form. Okay, that's it for a review of fractions, addition, subtraction, multiplication, division, plus a little bit of stuff about mixed fractions, improper fractions, and things like that.